So this is a Unit 8 seminar on factoring quadratic equations. Oh, my Bluetooth's falling out. Okay. Let's just switch that to a full screen. So, in order to, before we factor actual quadratic equations, we're going to learn to just factor algebraic expressions. And to do that, we need to know the concept of prime numbers. So like it says on the board, prime numbers are numbers that basically cannot be broken down any further. So they only have factors of 1 and itself. So if I wanted to factor the numbers 24 and 60, we're going to start by factoring using the greatest common factor. So 24, I want to break these numbers up into prime numbers first so I can figure out what is their greatest common factor. GCF stands for the greatest common factor. Okay, so can someone tell me what two numbers multiply to 24? Diana? 6 and 4, good. And what two numbers multiply to 60? Yep, Marvin? 5 and 12. Okay, good. So now we're going to keep going until we have prime numbers. 6 and 4 can be broken down further into 3 times 2 and 2 times 2. 12 can be broken down into 6 times 2 or 3 times 2 times 2. And then, so 6 times 2 is 12, and then we have the 5. Now notice I'm not separating by a multiplication sign because multiplication signs can be confused for the term x. So when you're doing multiplication, just always put like a little dot in between, and that means multiplication from now on. Now if I had to find the greatest common factor of these two numbers, you can easily see that the only thing they have in common is a 3 times 2 times 2. So for this particular scenario, my greatest common factor would be 3 times 2 times 2, or 3 times 2 is 6 times 2 is 12. So the greatest common factor between 24 and 60 is 12. Now if I change this question and ask you to find the greatest common factor between 24, 60, and 42, that changes things. First of all, what two numbers multiply to 42? 7 and 6. Good. So 6 times 7. Now my 7 is already a prime number, so we can put that there. But 6 breaks up into 3 times 2. So now I have to look at the greatest common factor of all three numbers. So first of all, they all have a common 3, and they also all have a common 2. However, 42 doesn't have another factor of 2. So we don't have, even though the 2 is common between 24 and 60, it is not common to the 42. That means it cannot be the greatest common factor. So the greatest common factor for these three numbers is going to be 3 times 2, which is equal to 6. Now we can also deal with the concept of greatest common factor when it comes to letters or variables. So if I had x, y cubed, and let's say x to the power of 5, and x squared, y to the power of 7, and I needed to find the greatest common factor between these two terms. Make sure you're copying notes because that's part of your problem set. To break down x to the power of 5, that is simply going to be x times x, and you do this 5 times. That's what x to the power of 5 looks like. X times x times x times x times x. And y to the power of 3 is just y times y times y. Now x to the power of 2 is just going to be x times x. Y to the power of 7 will be 7 y's multiplied together. So when I'm looking for the greatest common factor, I only have 2 x's in common and basically 3 y's in common. 3 over here and 3 over here.
Mr. Dalton, please come to the office. Mr. Dalton?
So my greatest common factor for these letters are just going to be x to the power of 2 and y to the power of 3. Now when you're dealing with variables, the easiest way to identify the greatest common factor is that it's always the smallest exponent. So when I compare the x, the smallest exponent is x to the power of 2. When I compare the 2 y's, the smallest exponent is y to the power of 3. Therefore, my greatest common factor is the two yellow terms I've highlighted stuck together. Okay, so that's a trick. But a lot of the time, you need to visualize it in order to really understand what you're doing. So always you can refer back to this slide. Okay, so before we go on to this, I just want to do a couple more examples with the greatest common factor, or using the greatest common factor to factor algebraic expressions. Okay, so what if I had the problem 7x squared y minus 21xy cubed, and you needed to factor this expression. First thing you have to do is look for the greatest common factor. Figure out what the greatest common factor is. So if I wanted to break down the first term, 7 is a prime number, so that stays by itself. You can't break that down any further. X squared breaks down into x times x multiplied by just y. The first term and the second term are separated by a subtraction sign. The 21 I can break down into 7 times 3 multiplied by just x to the power of 1 and y to the power of 3. So these are called factor trees. I've broken them down. And now I'm going to highlight my greatest common factor. So both terms have a positive 7. Both terms have 1x. And both terms have at least 1y. So that means my greatest common factor is going to be 7xy. That's my GCF. And now that I know my greatest common factor, I'm going to cross it out of the first term, or maybe we can just erase it. Cross out the greatest common factor, delete the greatest common factor from both terms, and that's the same thing as dividing both terms by the greatest common factor. And now inside the bracket, I'm going to write down what is left over. So for my first term, all that is left over is just x to the power of 1. The terms are going to be separated by a subtraction sign, and all that's left over in my second term is a 3. Y times y is y squared. Okay? So when you have